Section 7.2, verifying trig identities. Basically, we're going to be doing proofs. We're proving that certain equations are always going to be true. And that's what an identity is. So they start off and they give us some hints. Hints for verifying identities, or hints for doing these proofs that we're going to do. Okay? Hint number 1, learn the fundamental identities. Those are the ones from 7.1. You know, a lot of those you already know. Tangent theta equals sine theta over cosine theta. You know a lot of those. Sine squared theta plus cosine squared theta equals 1. That's an important one that maybe you didn't know. But learn those. You're going to use those kind of over and over again. 2, try to rewrite the more complicated side of the equation so that it's identical to the simple side. Okay? You're going to be looking at an equation. Whichever side looks more complicated, start with that. 3, it's sometimes helpful to express all trig functions in the equation in terms of sine and cosine. Okay, so this is a useful one. Basically, try rewriting everything as sine and cosine. Then see what happens. Some stuff's going to cancel out. Some terms are going to combine. It's going to turn into one of the fundamental identities. That's a nice little trick. Hint number 4. Okay, and this is probably the hardest one. Usually any factoring or algebraic operations should be performed. Okay? Basically we're using algebra. And I think this is where students really struggle, is because they don't recognize the algebra. Okay? So, you know, if I said something like x squared plus 7x plus 12, most of us would recognize that factors, like Algebra 1 class, into x plus 3 times x plus 4. Okay? I think we usually recognize that. But the problem is, I'm going to give you something that looks a little bit more like trig than like algebra, and you're going to forget all about factoring. Okay? If I said sine squared theta plus 7 sine theta plus 12, that's basically the same exact algebra problem. Okay? You should still be able to factor that. It's just that instead of an x, I have sine theta acting as my x. That would factor into sine theta plus 3 and sine theta plus 4. And so you're combining the algebra skills that you should be good at with the new trig skills and the new trig identities and functions that we're looking at. Okay? So also the sum difference of two trig expressions can be at. We're talking about adding fractions. So if I had like 1 over sine theta plus 1 over cosine theta, we're adding fractions. So treat this like you've always treated adding fractions. We would need a common denominator. And so basically you would give this one a cosine theta and you would give this one a sine theta so that they would have common denominator. You'd have cosine theta over sine theta, cosine theta, plus sine theta over sine theta, cosine theta. And the usefulness of this is that those two fractions can now be combined. You've got cosine theta plus sine theta over sine theta, cosine theta. So this hint number 4 is just talking about if there's algebra, there's going to be algebra, there's going to be fractions you can add together so you get a common denominator. There's going to be things that you can factor, or even things that you could FOIL. Get ready for that. I think that's maybe the hardest one. Hint number 5. As you select substitution, keep in mind the side you're not changing because it represents your goal. Okay? Basically what we're going to do is we're going to try to take either the left or the right side of an equation, and we're going to try and manipulate that so that it looks like the other side. Okay? We're going to end up with a true statement. And think about how we verify a solution in algebra class. You end up with a true statement like 7 equals 7 or 4 equals 4. And when we ended up with a statement like that, when we knew that it was a solution, this time it's going to end up with something like sine theta equals sine theta. We're looking for this true statement so we will know it's an identity. Okay? I don't know that this stuff is helpful, so I'm going to skip that one. And hint number 6. if an expression contains something like 1 plus sine x, multiplying both numerator and denominator by its conjugate, 1 minus sine x, would give you something that's useful. In this case, it would be if I multiplied those two things together, 1 plus sine x times 1 minus sine x, I would end up with this statement, 1 minus sine squared x. Now, on its face, maybe that doesn't look very useful to you, but if you remember the fundamental identity that says sine squared x plus cosine squared x equals 1, if you rearrange it, and by that I mean subtract that over to this side, you would see that 1 minus sine squared x is equal to cosine squared x. Okay? And so that trick, multiplying both the numerator and denominator by that conjugate, okay, is going to allow us to use the Pythagorean identity here and change that 1 minus sine squared x into cosine squared x. That's going to be a lot easier to manipulate. It's going to be a lot easier to use because something like cancel out or, I don't know, simplify. So similar results would happen for any of these statements. A lot of the hard questions in this lesson will use that property, and if you see one of those, a lot of times you're going to want to multiply by that conjugate. Caution, it says verifying identities is not the same as solving equations. For years, we've had equations like this, and we've always said, well, let's just divide both sides by 4. It's going to be very tempting for you to try to do that, but you're not going to be allowed to do that. Consider this. If I had square plus triangle equals 10, right? You have no way of knowing if that equation is actually a true statement or not, okay? Always before, when we had regular algebra equations, we know that's true. 4x equals 12 was given to us, and we took that and understood that it was a fact, and that's true, okay? But here, in these problems, when we are verifying, we don't really know. That's a question mark. We don't really know if square plus triangle equals 10. We're trying to prove that that's the case. And so you're going to be tempted at times to subtract triangle or something from both sides. You're going to be tempted to subtract something from both sides or divide both sides by 2 or square root both sides. We're not allowed to do any of that because we don't know for sure if this is an actual identity or not. Okay? That's what we're trying to prove. And so it says a lot of the times we're going to verify identities by working on one side. What that means is you're going to pick whichever side you think looks more complicated and try and simplify it, try and clean it up, try and combine left terms, use an identity, use some algebra, and try and clean it up. But you're trying to make it look like the other side. Our main goal is to make sure that the left side of this equals the right side of this. Okay? And it doesn't matter if you work on one side or work on both sides. What matters is you prove that the left side equals the right side. So let's look at an example. Example 1, verify cotangent theta plus 1 equals cosecant theta times the quantity cosine theta plus sine theta is an identity. Okay? So at this point, we do not know. I know it says equals, but we don't know if that's actually equals or not. That's what we're trying to prove. Okay? So one of your hints says start on the more complicated looking side. More complicated looking side looks like the right side to me. So you want to look at the right side and you want to do something to the right side. Okay? One of the very most common hints and tricks that you can use is to change things in sine and cosine. You'll use that all the time. And so this cosecant theta right here, cosecant theta, I know how to change that into sine and cosine. That's one of the fundamental identities. Cosecant theta is 1 over sine theta. So cosecant theta is 1 over sine theta. Let's just leave the rest alone. I'm going to try really hard to line everything up. Okay? I'm going to try and keep that right side underneath my right side of my equation. But I've got 1 over sine theta equals the quantity cosine theta plus sine theta. Usually what happens is after you use one of the identities, you'll be able to do something algebraically and something's going to cancel out or clean up in some way. And so you might be thinking, well, what if we distributed that? Okay, we're allowed to do that. Distributive property would give me cosine theta over sine theta plus sine theta over sine theta. And the very best of you are going to be able to look at that, and you're going to be able to plan ahead. Because remember, one of the hints said to keep an eye on the other side. Because that's our goal. That's what we're shooting for. Whatever we're working on over on the right, we want to try and make it look like what this is on the left side. We want to prove that the left side equals the right side. And so the very best of you can probably see how it's going to work. Okay, usually something's going to cancel. We're going to use an identity, something's going to cancel. And so I see right here, cosine theta over sine theta. I know what that is. That's one of my identities. It's one of my fundamental identities. I know that is cotangent theta. And that's good because I want cotangent theta. Okay? Plus, if you know that sine theta over sine theta is going to cancel out and be 1. And so I have exactly what I need. I have my right side equal to my left side. And as soon as you get that, as soon as you get left side equals right side, you're finished. Okay? And you don't have to write LS equals RS, but that's what you're looking for. Okay? When you're finished, you're going to write QED. Okay? QED is a Latin acronym. Quod erat demonstrandum. And you're probably going to recognize one of those words. Even though you don't speak Latin, you're probably going to recognize one of those words has something to do with the word demonstrate. Okay? I was asked to prove or verify that that equation was an identity, and I just did that. I just demonstrated what I was supposed to do. So do not circle QED, because QED is not your answer. QED is like the period at the end of your sentence. Okay? This is a proof, and so the entire thing is your answer. QED is just how you show you finished. And you did what they asked you to do. Example 2, verify. So we see this expression, and one of those hints that I gave you is start on the one that looks more complicated. Okay? So most of the time, I think students will agree that that it looks like the left side is more complicated than the right side. So let's look at that. Okay, look at the left side. So a couple of different things we can do. One thing we can always do is change everything into sine and cosine, and so that's something to keep in mind. When in doubt, if there's nothing else I can see, that's what I'll do. I'll change everything into sine and cosine. But if you look back at your identities, I see one of those identities popping out. Okay? When I see that 1 plus cotangent squared right there, it makes me think of those Pythagorean identities. And here's kind of something to look for. If you see the number 1 and then one of those trig functions is squared, a lot of the times that's going to be one of your Pythagorean identities. Okay? Specifically the one that says 1 plus cotangent squared theta equals cosecant squared theta. I have half of that identity. And so what I can do is I can substitute 1 plus cotangent squared x is going to equal cosecant squared x. So again, try to keep this lined up. You don't need to put that line in there. You don't need to put that line in there, but try and keep the left side on the left side. So if I use that identity, I've got tangent squared x times cosecant squared x. Okay? And you're looking over at the other side, and you know that's kind of the goal. That's what we're trying to get to. Maybe we don't really see how that works yet. Okay? When in doubt, a good thing to do, though, is put sine and cosine in. Okay? You can change this into terms of sine and cosine. A lot of the time, something nice happens. So tangent squared x is sine squared x over cosine squared x. I'm using the identity that tangent is sine over cosine, and I just know that they're squared. So tangent squared equals sine squared over cosine squared. Now cosecant squared x, cosecant squared x is 1 over sine squared x. And so what's going to happen is this. You're going to use those identities and write down a step, and then hopefully you're going to see something algebraic that will happen. Okay, a lot of times something will cancel out. Notice what happens here, what cancels out here? Sine squared is going to cancel out, leaving me just 1 over cosine squared x. Okay. And this is the point where the best of you will probably be able to see how to finish this off. I need the left side to equal the right side, and so maybe if you know about your identities, maybe you can see how to make that happen. There's not one right way. There are multiple right ways of doing this, but my general rule is look at the side that's more complicated. Okay? Look at the side that's more complicated, and in this case, I think the right side is more complicated now than my new left side. And so I know this direction says working with one side, but I'm going to go ahead and do this using two sides, just to show you what it looks like. So I'm going to switch gears. I'm going to change gears. I'm going to go over to the right side now. 1 over 1 minus sine squared x. Now, again, when I see that number 1 and one of my trig functions is squared, that reminds me of my Pythagorean identities. Okay? So, again, I'm going to shortcut this. I know it's not technically accurate, but I'll abbreviate it. Sine squared plus cosine squared equals 1. I have 1 minus sine squared, so imagine if I had subtracted that over. I know that 1 minus sine squared is equal to cosine squared, according to that Pythagorean identity that I have. And so what I can do is I can change that bottom from 1 minus sine squared x into cosine squared x, and that's exactly what I need. Okay? At that point, I've just shown that the left side equals the right side. That's exactly what I need to do. Left side equals the right side. I'm going to want a QED at the end. That's not the answer. Again, QED is not the answer. It's more like the period at the end of the sentence. The answer is basically everything I've written above. Okay. Example 3, we're verifying this one. Again, you would want to start with whichever side you think looks more complicated. To me, it looks like the left side is more complicated. So we've got this fraction. Usually fractions are kind of tough. But you don't really see what to do. One thing you can always do is change things into sine and cosine, I suppose. But what I'm going to do is I'm going to split up the fraction. Okay? I'm going to split up the fraction, and that's going to say tangent t over sine t cosine t minus cotangent t over sine t cosine t. Try to keep your left side lined up with your left side in case you want to switch over and start working on that right side. But all I did was split up my fraction. Imagine if you had x minus 5 over 7. That's the same thing as saying x over 7 minus 5 over 7. That's all I did. Okay? All I did was I split up into two fractions. Normally, you wouldn't think that would help, but it does when you're trying to cancel things, and that's what's going to happen. Hopefully something will cancel out, and I can clean this up, and it will look more like the right side. It looks nothing like it at this point. Okay? So, what can I do? What can I do? Well, I can change things into sine and cosine. That's a good strategy to use when you're stuck. When in doubt, change things into sine and cosine. So that tangent t is going to be sine t over cosine t. And over here, that cotangent t, that would be cosine t over sine t. Everything else can just stay the same for now. I've got this super complicated looking fraction. Okay? Two super complicated looking fractions. But notice you're dividing fractions. And something that we always do when we're dividing fractions, what we should always be able to do is multiply by the reciprocals. Okay? If you notice you're dividing fractions, maybe it would be a good idea to just multiply by the reciprocal. So that's sine t over cosine t times 1 over sine t cosine t. Okay? If you look at that, you see something that's going to cancel out there? something's going to cancel out. This is going to be nice. Okay? This is going to work for us. Minus cosine t over sine t times that reciprocal 1 over sine t cosine t. So again, the very best of you are going to see what cancels out. You're going to see what's left and what that turns into, and you're going to be able to see that how that matches up to the right side. You're going to be able to plan ahead like 2 steps, okay, maybe 3. I can usually do about 3 steps ahead, okay? So, see how that sine t cancels out? That leaves me 1 over cosine squared t minus over here. You see how that cosine t cancels out? Leaving 1 over sine squared t. Now, every time I clean something up, I'm going to look back at the other side and see if I can make those two the same. And maybe you see it right now. I know 1 over cosine. 1 over cosine is secant. Okay, so this is going to be perfect. This is going to be perfect. I can see that 1 over cosine squared is equal to secant squared t, and 1 over sine squared t is going to be cosecant squared t. That's a perfect match. Secant squared t minus cosecant squared t. That's what I want. Okay, that's what I want. And as soon as I see the left side equals the right side, that's how I'm going to finish. So you're going to write QED, and that's going to let everybody else know that you're finished. Okay? QED, again, is not the answer. That's just a period at the end of the sentence. Example 4, verify. Okay, it's tough to say which side is more complicated. I would say maybe the left side because the denominator is more complicated, but I don't suppose it matters. We do have a trick for how to deal with this. Okay, one of the hints that you were given earlier said if you ever see something like 1 minus sine, then multiply by that conjugate in the top and bottom. Okay, so basically what we're doing is we're multiplying by a special form of 1, a very special form of 1, but that's going to make something shake out on the bottom. Okay, so if I multiply by that 1 plus sine x over 1 plus sine x, I'm going to have on the top 1 plus sine x times cosine x. Okay? But on the bottom, 1 plus sine x times 1 minus sine x. Remember in algebra, if you did 1 plus x times 1 minus x, that would end up being 1 minus x squared. Okay? That's a basic algebra thing that you should remember. 1 plus sine x times 1 minus sine x is going to be 1 minus sine squared x. So 1 minus sine squared. Here's kind of a hint for you. When you see the number 1 and something squared, it should kind of give you a signal that it's one of those Pythagorean identities. And there are 3 Pythagorean identities, and if I see a 1, I see a sine squared, I'm thinking maybe that's equal to cosine squared. So remember, I'm going to shortcut this, but sine squared plus cosine squared equals 1, right? Okay, so if I needed 1 minus sine, so subtract the sine squared, you would see that cosine squared equals 1 minus sine squared. Okay? 1 minus sine squared is equal to cosine squared. And so that's something that should come to the front of your brain. It comes up kind of a lot. 1 minus sine squared is going to equal cosine squared. And so I know this right here, denominator, is going to end up being cosine squared. The top is kind of messy, 1 plus sine x times cosine x. And that's going to be all over cosine squared x. And again, generally what happens is you're going to use an identity and then use algebra to cancel something else. Okay? So hopefully you can see what's going to happen. Those of you that are good at this and those of you that are going to be good at this are going to be able to plan ahead like a step or two. Okay? And you'll be able to see what's coming. Okay? If you can't see what's coming here, then you need to practice probably. But one of these cosines is going to cancel out. Okay? You know, if I had x over x squared, I cancel out one of those x's, I get 1 over x. Okay? The cosine works in the exact same way. I cancel out one of those cosine x's, and it's going to leave me with a cosine x on the bottom. We got 1 plus sine x over cosine x. And that's exactly what I wanted. Okay? At that point, you can see the left side equals the right side. And when you have the left side equals the right side, you know you're finished. Example 5, verify. When you look at this thing, it's kind of hard to tell which one is the more complicated side. I don't know, maybe the left side. But when I look at the left side, I don't really see any identities other than I know I could change everything that sine says. So maybe that's where I start. Okay? Secant alpha would be 1 over cosine alpha plus tangent alpha would be sine alpha over cosine alpha. You don't know how to make an alpha. Imagine making an x but not picking up your pencil. Okay. On the bottom, you've got another secant alpha, so another 1 over cosine alpha, minus another tangent alpha, so minus that sine alpha over cosine alpha. Pretty complicated looking fraction, a lot of stuff going on. Okay, but when I'm dealing with fractions, you should notice here that you've got a common denominator. Okay? You've got a common denominator of cosine alpha, and so you should be able to combine those two fractions into one expression. Up on the top, you're going to have 1 plus sine alpha over cosine alpha. On the bottom, in the same way, you combine those fractions, you get 1 minus sine alpha over cosine alpha. And at this point, I hope that you can see what's going to happen. Okay? What's going to happen is those cosine alphas are going to cancel each other out. Okay? I hope that you don't have to do this work, but if you didn't see why that happens, you're dividing fractions, and so you could think about multiplying by the reciprocal. Multiplied by the reciprocal, maybe that's a little bit easier for you to see why those cosine alphas cancel out. But either way, if you show your work or not, you're going to get 1 plus sine alpha over 1 minus sine alpha. Now keep your eye on the prize. Now you're always trying to notice the other side and see how you can reconcile what you've written with what the other side says. And it's kind of hard at this point to see how those things are going to match up. Okay? And so this example says working with both sides, so they want us to go over and work on the right side for a while. I definitely do think the right side is more complicated than the left side at this point, but I'm not so sure that's the easiest way to do this. Okay? So let me show you what I think maybe we would do. This 1 minus sine alpha on the bottom, we know one of our hints says with that 1 minus sine alpha on the bottom especially, we should be able to multiply by 1 plus sine alpha over itself. I think that's going to be a good thing for us to do. That would give us 1 plus sine alpha squared. So 1 plus sine alpha times itself. And on the bottom, we have 1 plus sine alpha times 1 minus sine alpha is 1 minus sine squared alpha. It really, really helps to know your algebra here for some shortcuts. If you don't know algebra, you're going to have to FOIL this stuff out. And I don't think anybody wants to do that. Okay. Now again, you want to look at what you have and how you can reconcile that with the other side. Are those two things equal? And maybe we can see that they are equal. Hopefully we can plan ahead there. But if you actually expanded that top out, 1 plus sine alpha, okay, so we've got 1 plus sine alpha. Maybe I shouldn't have condensed it. Maybe I should have just FOILed that together. If I look at it as quantity times itself, when you FOILed that together, You're going to have 1 times 1 is 1, and 1 times sine alpha. You have sine alpha plus another sine alpha, so there's plus 2 sine alpha there. And sine alpha times sine alpha is plus sine squared alpha. That looks familiar. That's what the numerator says. And then on the bottom, you have 1 minus sine squared alpha. Well, we've seen a few times before. Use that Pythagorean identity. That's cosine squared alpha. So they're a perfect match. I just did what I needed to do.